Hey everyone! Today we're diving into a fascinating topic, Archimedes' Principle. Named after the brilliant ancient Greek mathematician Archimedes, this principle explains why things float. It's all about buoyancy, and it plays a crucial role in everything from ships sailing smoothly to why we can enjoy a relaxing swim in a pool. Ready to grasp the magic behind why some things float while others sink? Let's get started. Archimedes was a real pioneer. Think of him as the Einstein of his time. Living in ancient Greece around 212 BC, he made groundbreaking discoveries not just in buoyancy, but also in mathematics and physics. His thoughts were revolutionary and took the scientific world by storm. When he discovered his principle, it wasn't just another science fact. It changed the way we viewed the physical world. Imagine the wonder back then, realizing how objects behave in water, laid the foundation for future innovations in physics and engineering that shape our world today. So, what exactly is Archimedes' principle? It states that any object fully or partially submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid it displaces. That sounds complex, but in simpler terms, if you put something in water, it pushes some water out of the way, and this water pushes back with a force. This force is what allows boats to float and some objects to stay afloat, and it's the key to understanding buoyancy. The beauty of Archimedes' principle lies in its mathematical formulation. The buoyant force can be calculated using the equation Fb rho times g times v. Here, Fb is the buoyant force, rho is the density of the fluid, g represents the acceleration due to gravity, which is about 9.81 meters per sequators on Earth, and v is the volume of the fluid displaced. For example, if you were to drop a rock into water, you could measure the volume of water it displaces to determine how buoyant that rock is. Pretty neat, right? Archimedes' principle is everywhere around us. Take ships, for instance. They float because they displace enough water to counteract their weight. Now there's also the fascinating world of submarines. They use this principle to dive and rise by adjusting their buoyancy, taking in or releasing water to move up or down in the ocean. Let's not forget about hot air balloons. They float high in the sky because the hot air inside is lighter than the cooler air outside, giving them that uplifting force. From recreational activities to engineering marvels, understanding this principle empowers inventors and designers to create incredible things. Each time you step into water, you're experiencing Archimedes' genius. Ready to see Archimedes' principle in action? Here's a fun experiment you can try at home. Grab a bowl of water, some small objects like a coin, a rubber duck, and a pebble. Fill the bowl, then drop each object in one at a time. Observe how the water level rises. Each item displaces a certain amount of water. Notice how the heavier objects might sink, while the rubber duck floats. Measure how much water is displaced using a measuring cup for deeper understanding and visual proof of this amazing principle. There are a few common misconceptions about buoyancy. Some folks might think that all heavy objects sink, but that's not true. It's all about density. An object can be heavy but still float if its overall density is less than the liquid it's in. For instance, a giant metal ship floats thanks to its design and the air inside it. Understanding these misconceptions helps clarify how buoyancy really works, which is critical for science enthusiasts and budding engineers. To wrap it up, Archimedes' principle is not just a math equation, it's a powerful concept that helps us understand the world around us. Whether it's ships sailing smoothly or hot air balloons soaring high, this principle truly impacts our daily lives. So next time you're in the water or see a boat, remember Archimedes' genius at work. Keep exploring, stay curious, and who knows what other incredible scientific principles you'll uncover in your journey. Thanks for watching.